Hi students, welcome to the session on types of media and its characteristics. Right, so this is very important before we go and start our study on wave propagation. Right, so first we see some basic types of media. Media is divided into 5 types. One is homogeneous medium. Right, so homogeneous medium. What is homogeneous medium? A homogeneous medium is one in which all the media constant epsilon, mu, and sigma are constant. We know that epsilon, mu, sigma are constitutive. We have seen this in constitutive relations. These are describing the characteristics of medium, right? Epsilon, mu, sigma. So these three values are constant throughout the medium. If these three values are constant throughout the medium, that medium is known as homogeneous medium, right? The best example is free space. Okay, so free space is the best example for homogeneous medium. Second one, non-homogeneous medium. Non-homogeneous medium. What is non-homogeneous medium, right? Opposite, right? So these three values are not constant and different for each epsilon, mu, and sigma are not constant all through the medium. Fine. So and they vary from one point to another point. For each point, the value will be different. The best example is our human body. Fine. And third one is isotropic medium. Fine. So what is isotropic medium? Isotropic medium is one for which these parameters are simply scalar, right? So epsilon, mu, sigma are direction independent, right? Direction independent. What do you mean by direction independent? These quantities are only scalar because scalar is independent of direction. Again, the best example is our free space. So free space is a homogeneous medium. Free space is a isotropic medium also. Fine. So right. So what about fourth, non-isotropic or anisotropic medium? Anisotropic medium is one in which epsilon is not scalar. Epsilon is not scalar constant, right? Whereas it is a vector, right? So the best example is again human body. In our body, epsilon will vary with respect. It has vector quantity. It is a vector quantity, right? And fifth one is source free region, right? So source free region. I have dealt one full video on source free space. Please refer that video, right? So what is source free region or source free medium? In which there are no sources. A medium in which there are no sources to create field. Then you can ask how source will be created, how field will be created without source. The source is not explicitly present, it is present somewhere else, right? So detailed analysis is given in the free space. Please refer that video, right? So and some other things we have to remember when we go and study about wave propagation. What is that is free space. In free space, I will say, so we are going to study wave propagation in free space, right? And lossless dielectric, right? Lossless dielectric, lossy dielectric, lossy dielectric, and conductors, right? So these are all the media we are going to bother mainly. So we must know the characteristics of these media important, right? So what is free space? In free space, conductivity is zero, right? Any medium is characterized by sigma, mu, epsilon. So in free space, conductivity is zero. Epsilon is equal to epsilon naught. Mu is equal to mu naught. These are all characteristics of free space, right? And there is no sources. It is a free space, a homogeneous medium. It is isotropic medium, right? That is very, very important. that lossless dielectrics have a conductivity 0. We know dielectric is insulator, so conductivity is 0. Epsilon is equal to epsilon naught epsilon r, and mu is equal to mu naught mu r. Right, and one more thing we have to remember is sigma must be sigma by omega epsilon, or sorry, less than 1. I can say like that, or sigma must be far less than omega into epsilon. This is the characteristics of a lossless dielectric. Now we see what is the characteristics of a lossy dielectric. Lossless means it is ideal insulator. Lossy means it may conduct. So sigma is not equal to 0. Conductivity will be there. And say epsilon is equal to epsilon naught epsilon r. Mu is equal to, mu is equal to mu naught mu r. Right? So those are other characteristics are same. Sigma is far less than omega epsilon. And for good conductors, conductivity must be infinity because it is a conductor. And epsilon is equal to epsilon naught, right? And epsilon naught epsilon r, mu is equal to mu naught mu r. And another thing is sigma must be far greater than omega epsilon, right? Where omega is an angular frequency. Clear? So that's what we have to remember about media we have to work with. Okay, I hope please understand and memorize these characteristics because it is widely useful when you derive some very good equations in the coming session. Thank you.